你看我开给你看，这个开进去 ，and then 你要 share screen 它。share screen mana share screen？哦，对，哎，你比较会，你真的比较会。Windows 是不是？呀啊，就这样，就这样，它就上去了。OK，然后 make sure 他们是 full screen，他们上来他们一定乱了，等一下，这个跟它关掉吧。这样就在 record，要看到这个东西在，它才会 record 着。
我只要看到这边有这个东西就可以了，对吗？
嗯。然后 make sure 这个上去的时候有这个框框，不然的话它就是录它罢了。啊，就这样吧。
可你坐前面不是？
啊，
可你坐前面不是？
我怕我会忘记的时候，我专心我就忘记了。他们去找椅子啊，那个顺明跟那个。
你现在录这妹妹？
我已经开始录了，我可以看的。录好过不录不是？还是怎样？
我还不是一个改名，然后我
你可以改啊。
其他人没有的话，我怎样？
没有，我只是开录罢了。
还没
我怕等下忘记按。
还没有那些。
记一下这边啊。
这个放上去，你放上去。
等一下我会讲一下，他让我们自己熬录还是这样？
他的脸，
你放空哦。你放空，还没意思。
你不用剪，放上去，我等下做一个精华。表情包。
你讲一边讲的时候，你这个东西要开着放那边，你讲。
他要
还是怎样？用这手更好看。
大小子拿一个椅子来。我应该拿一个 stand 来的，真的。因为我讲我应该要拿一个 stand。想到他这样子了吗？
哎，你知道刚刚我差点。
我。然后。
开的是
东西发给我。全部东西发给我。
我现在又没有空理你朋友。
等我按下去嘛，我还不开呢。
他们有些人的发还没有进来，然后那个顺序是不一样的。
啊，你要什么顺序？
那通常都是要拿。这个是第一轮跟第二轮。
然
后这个两个都谁懂那个是哪一个哦？
你全部让它拉开，然后再什么？
我现在要 rename。
没有，你全部拉开先。你把 first group second group 拉开那分两个就容易了。
哦。怎样？
要不然
这边开。
你先找啊，你 first group 是要什么？全部给它选出来先。first group 谁？点找那个人，然后 control 再点。没有 back 啊 ，control 继续点。
我差点就跟人家干架，怎么办？recording 在录着。听见安哥在那边。recording 在录着，没办法讲话。I'm so sorry。就被录进去。
哎，你要做计时的还是怎样？还是怎样？我怕你
什么
会累吗？
累什么？
计时哦。
不会啊。
OK，那这样我们讨论一下。
等一下，我想一下。
跟他一起，以前你跟他讲一下，如果他能够帮你这样，先跟他讲要做什么先，然后如果你有什么，他可以帮你。OK， 看 Gilbert 表情。来，
安哥 ，come，
快
点算。人太多会乱了。
来，
有
一个要听不了。其他的帮忙看
还有一个新的for的。
有哦喂。
对，这边开要比较快啊，这边开。
有啊。
你们大概
这边。
第三，
这个还是
就开始时间。 当然是跟着他啦，他的叮叮叮啊。但是你觉得你好像他可能超过30秒，那么他还没按你，对你
哦，你可能要找过，跑完了，直接跑完然后把它丢进去，
对1分钟过后，
然后把那个选过全部给它丢进去。
对，这个可以让他一开始讲就开始按1分钟，你们自己可以拿
就做哪一个？
然后他1分钟
进来，
如果他超过可能9秒20秒还没定，你快点叫他。
OK，
然后
这样子看过去了 OK。
就是
请问最后一个什么？
又看不懂他们找
不可以
去了。
低了过后再1分钟，这样。
他不还需要自己开，
然后他们的
不能自己
presentation 最多2分钟吧，所以1分钟顶
进啊，
2分钟，
掉，
就要几秒。其实他们如果他们还要继续讲的话，我们给他30秒，然后就叮，然后就卡掉了，不要到疯狂。我
你看那个拍图，现在直接这边全部拍图了吗？
啊，随便
1分钟一次，
这边调都可以啊。
1分钟一次，前2分钟2次，然后
我最需要干嘛？就是一开始我看我哪一部忘记了，因为我们开了这个号。
对 presentation 啊，Q&A 也有的
make sure 它是完全
对一样的。
然后我们就要去 Teams
对，你们
去 share
直接就看那种延迟，不是给
这个 Windows 的啊，然后按这个就可以了。
可以新了，然后再
差不多它有开完了，
等一下，
然后就给他们自己弄。
你不要想，
是该一开始我的他可能是忘记哪一部，你可能可以讲一下。换一下他们的名字，因为有些 file 还没有进来，然后我也不知道老师怎样打算。先换名字，你帮我看一下第3个是谁？就是 group 2 part 2。
反正是
0
哪一个他讲一下大概有什么？等下有发生什么事，他可以发。
看我坐这边不是？
你啊，坐这边附近，这边
你看你跟我讲的东西，我就跟他讲。
OK， 好，可以。
然后
会明白吗 ？OK 啊，
现在那些没有发问人，我现在怎么办？
就先停在那边哦，管他哦，让他放在那边先，等下他会放进来啊，
就进来这边了，
会直接
对吧
进来这边，
？OK，
他们全部都要上进。
是谁？
谁没有进？
海分好像就没有进啊，
哦，iPhone 没有进啊，这样我们就
他好像第一个对吧？
Yeah，
那个什么，燕如没有，不是是哦，是这个，第2row的 support 应该都出来了，除了晋升还没有。
竞胜也没有。iPhone 跟竞胜哈，叫我直接 tag 他们。
一个好像不知道 part 1还是 part 2，我忘记了，等下我 check。是昨天是我。
iPhone 的名字不叫 iPhone，哦，去错 group。
你在解决 part 2的事情，就是
那来跟我讲话会有，
不是 part 2，
我会乱，我知道，不要来感觉我了。
叫我过来问你。
问，我听到了，其实。
哦，好
iPhone
的。
跟谁来着？竞胜。
强迫症，有东西我会，8有2个，我就开最近的。
行。诶，还有 unemployment 啊？
是就算精算，然后 part 1的话是 OK 1、2，1没有 OK 2，然后3是7，这是8吗？还是9？这个好像是9。好的，part 1是谁？
承认在说话。
没有啊 OK。
我那时候青菜传的。
还有的话就是，其实这边只有7个人哦。这是6，这是2。懂我意思哦，因为哪一本第一个嘛，然后叶如没有讲嘛，所以他这边第一个，然后你也没有讲的话，就这边就7个人。
什么东西？听过什么？啊，
对，不拿了，presentation 不拿了，老师可能我那时候好像不认可。
不懂就好。这以后记啊，因为你们是加入我的，
剩下就等了，
过100万不是吗？
等他本来有。
我太多啊，没见过万次。这样，
6分的话可以卖。
6分。
哦，卖不可以2只开，
impression
就是
impression
我也不知道为什么啊，反正就是一只开着的话，另外一只关掉，不然它找不到人。
好，评价。
Nanti dulu ah, nanti kita suruh dia. 卡的全部录进去了，还在这里改。没有声音，这小房子里面是。好是你。讲2.5要跟一条就直接系统的，我写了300多还是多少钱的？说的讲了，
喂，他说不知道你们去看我们这么。高飞车，哎，然后今天。
理解。也是个。
是我 pass 了后面那个一些的线，是那不用了，那不用。
动身生神，
是吗？
卖在这里，卖在这里。
没有。
看一下，去看一下，在这里，在这里，看一下。在这里，等一下会介绍。
哦，我们认识一下呀，叫什么名字
？Hello。
喂，没有看。
Hello，
喂，没有看。
有啊有啊。
不对呀。
啊，有啊。
同学们好，希望只有这么多同学，不要再来了。
大家休息时间就出去10分钟一下，很快的。就出去10分钟，用好你们的时间，对。没有，你们就出去10分钟，不然你们就听不到任何东西了。
我明白啊，对不起。
应该的比生的10分钟，不是谁的钱的10分钟，因为真的我也是要叫我出去啊。
是现在中场休息了10分钟，对不对？谢谢哦。
水拉湖，
OK，
水拉湖，
对，
水拉湖。
我要花等下你帮我反多久？
我
那台上表演
在这里，还在背。
你在这边，这边，
好一点哈。
不会不会，没有，你叫我坐这里。
不要这边有顶到人家。
你是讲不是，我是摆线。
白天，
我班第9位。
哎，等下就可以直接摆。
这张表分哪？这色了，我不是第一个。我真係咪讀？唔可以開嘅，就可以開。我會使喎，
看到啊。
會使啊！等下有關。你關了就吹吧。
我觉得很亮了哎。
要表演嘛？对呀。关灯比较好看。
关灯啊！我在这里关，你关了
關了看。關呢？關呢？
我要再加上眼镜做掉，这很好，有没有？
關。
戴眼镜啊。
前面拆掉吧，真的。啊，好一点。
老师，你拍过东西哎？可是等下问问题，那就拍。老师，你拍过东西？
要我看吗？
拍不到东西。你的 video 拍不到东西，我 video 拍不到东西。
你要拍到。
不会的，
还有，
不会的，
你可能会出来。
会没？把紧张丢掉，
啊？
紧张这个去掉，那怎么？
哎，我可以，我要去掉哎，我不要啊。
你这个椅子不要放这里。
我知道我不，我只是快18了。
有inside one。
可以，但是我强迫症发作，我必须要全部名字就是。
Everything inside one 的。You thought honey mean can also inside one 哦。
I know.
Later they see me play。
I know.
看一群人在前面发神经。
啊？要把这名字改掉。
看
我真的不可以。
看我。
真的不可以。
等一下那个，我不能现在啊，我讲了他们就知道我要。
拜拜。
哎，哥嘛，在Part 2。这我问的特别专业那个。呀，this person。呀，you click inside。
我不知道，你讲的话。
讲，谁讲谁？里面啊，好吃吗？
我们要去圣马金山来去啊，那个门就给出来讲，这就够了。可以，完美，这个几块钱。OK，这个是金山。
没有了，他决一个嘛。
我们全部
一个人。
他的花好像也没有进来哦。金色的花我也没有进来。
金色还没有进来。
我会打电话叫我律师电话。
可以把这个人叫呀。
这个人是谁？综艺啊？
我把他，因为他被人
综艺，你的 file 哪一个是你要的？
可以。多少 delete 啊？delete 掉。
08标。
delete 掉啊。
delete 掉啊，综艺 delete 哦。
delete 掉啊。
08 delete。
已经 delete。也是两个，跟着最新的。
有缘你要哪一个？哎，有缘呢？
跟着最新的。
他应该是我们5发那一个吧？
啊，那你觉得哪个女的？没有，你点去看他。
我怕删错号不好？
两个是错号。
我怕我 delete 错号。点到外面。
他是讲他没有做完了，所以他是刚交一个新的嘛。
那就开心了呢。
等你开心的时候。
你紧张吗？啊，紧张吗？我已经不了，
点就开始紧张了。
我最近不要，你不要紧张，我会给你拍到的。
汉伟，上半身对，哎，对，上半身发的，
什么意思？因为这关
干净的。
哇，太难说了。
小波懂
啊，你说很亮的衣服耶，这边
看最亮，你包上面到多少人？
可以，加头。
Hello. Okay. Since all the MAT230，金生不要走，我们要拍照一下。So I will wait, sorry. I will take photo with the class of 2304 first, and then we take a group photo together. Okay or not before we start? Is that okay? Okay. So all the 2304, can you just move your seat first? You can put your stuff there, move your seat, and then we take a group photo. Take a group photo, and then we'll take a group photo with the participants also. Okay, huh? Calculus 2, right? Let's move to this side. We take a photo. Okay. Yeah. And Hangwei also move front, Roland move in. And then we all take a group photo here first. And then 来 2, 3， 等一下先拍一组他们班的组。Yeah, and then 我们 yeah, you have take photo, okay.
不能在这里录啊。
没有了。
就是阻止你逼逼的场。
我坐这。啊，还有语言，等一个语言。我坐那边 ，OK， 我坐那边。OK， 等一个语言。
1分钟里面。
很好笑哎。你现在就相处针锋相对。
没有开密码。
是外面的拍照来的。
为什么这样？
直接看了里面。
安静啊，他要发言了。
他这个框
啊 ，Hello。
这边还有，
你出那个框还是
我搬起来。
我来搞的。
拍得到吗？
你们是前面的顶梁柱。
1, 2, 3, 1. Anything else? Anything else?
我觉得有哎，你要人跟我有点
不好意思得罪人呢。
OK 啊。
这样的啊，这样都可以。Quality check。
没关系。
AI 还没有来，我们要不要先照一张，还是等 AI 来？等一下来，这样要到晚的时候，应该。没有很多，啊？代一的是 renew 的 Michelle 啊，那个有缘的。Okay, thank you. So let me brief first before we start. So what's the rule for today? So let me brief for what's the rule for today. Everyone. Okay. So there are few mics here, okay? Few mics here. So there's one mic here, okay, for the speaker. So after you speak, everyone speak, right? After you speak, turn off your mic, okay, so that the other mic can work. Okay, every time you finish speaking, you need to close your mouth, right? Close your mic. Okay, turn off your mic. Whenever you want to talk, open your mouth, open your mic. Okay, close your mic, off your mic, because there's only one mic can work each time. And then, so for the talk, you have 1 minute for your presentation. The second minute, you should answer your 2 questions, and you have 2.5 minutes extra. Okay. And first minute, we will have a first bell ring. So first bell ring is like, please try it out. First bell ring. Try it out. And so you will have a first bell ring, all the speaker take note. First bell ring, 1 minute. Okay. Second minute, you will have 2 rings. Okay. If you can. Okay. So if in the event you go over, right? Okay. In the event you go over 1 minute or over 2 minutes or over 2.5 minutes, I will depend on situation. Okay. I will cut you at the 2.5 minutes wherever you stop. Okay. If your things is making sense, still ongoing, I'll let you go. Otherwise, I'll just cut you. Okay or not? Because we have second session. Second session, people will ask if you are not clear in your explanation. Okay, so the second part, 2.5 minutes, is for you to answer questions, to make your argument clear. Okay or not? Make sense, huh? Okay, and then so for the rest, you could ask questions during the Q&A section. Okay, and then I will pick. You can raise out your hand, and then I will pick which one goes first, and so on. And we also only have 2.5 minutes for Q&A. Okay, asking question and answer questions both. Okay, so time is very precious. So if you can talk as fast as you can. Okay, but clear as fast as you can, but clear. Any question? Okay, so priority is if I have question, I will ask first. Okay, because I want to check whether the speaker know about something or not. And then the second priority is for the current class students. Okay, because they will get marks if they ask a good question. Okay, so you will get, so please listen to your friends when they present. You can ask questions to them. Okay, if you ask good question, you will get extra marks. Okay, for the 2, 3, or 9 calculus. Okay, and then the other, we will turn to the other to ask. Okay, does that make sense? Okay, so that is okay. Any question or not from the speaker or from the audience? If no question, then we're going to start soon. Turn off light. Okay, we will turn off the front light. And then the first one, we will invite Ivan. Ivan is the first one for today. tell us about Fibonacci sequence in the plot. So when the speaker start, then you can.
哪一个？
over.
在哪？ Hello. Okay. Okay. I'm Ivan from MAT. Student ID is at MAT2304236 from the DM. My topic is Boolean sequence in plants. And now at the first, I want to introduce about what is the Fourier sequence. The Fourier sequence is a series of number that one is the number is going to 0, 1, 1, 2, 3, 5x, and then and others. Then we can know about the formulas is n is equal to an minus 1 plus an minus 2 when n is bigger than 2 lah. For n is all natural number, and also for the general formulas is n equals to that one is the general formula. When you plug inside n equals to n equals to 0, n equals to 1, 2, and others, all the thing you can find out all the numbers inside of the sequence there. The next one is the key character of the Fourier sequence include. The first one is stiff probability subject. So because it's adding of the in front of two numbers, so just now for the number is 0 plus 1 equals to 1, 1 plus 1 equals 2, that then 1 plus in front, and the limit graph. And we put it the limit to the n is equal to pi is 1.661x is equal to golden ratio. And the first one example inside of Fourier sequence in plants is for meters. For example, that we can see in the picture, the first one is got 3 meters in one, and then the second one is the club has 5. The third one is Prajika if data is 8, and then 2 1 is sunflower with 31 and 34, and then this is 34 and 55. They are also follow the Fourier sequence. And then the next one is the leaf sequence. And this is the explanation about the leaf sequence. And then for the normal I explained is for this one, for the one that we can know if they have one Fourier weight and then they got only for 3 that they want their all number is also for Fourier number. And also why they are planned Fourier sequence like this one is the explanation now because of they are easy to grow up and then to receive all the things. And then so it's finish. And then for my question, how does math interest for with my living? I think that math is everything. Right? Math is everything. So I think a lot, and I learned from math is I want to learn more about the rules of the world, the roof of the all the things. I think all the things is built by math also. So the first choice that I choose for math. Thank you.
Okay, thank you. Thank you, Ivan. So it's Fibonacci sequence, not.
Oh, sorry.
Okay. Okay, so any question from the MAT student first? Question? No? Yeah.
Wait, wait for the mic.
Okay. So just now you have shown that the Fibonacci sequence has the general formula which involves like 1 plus root 5 over 2. Yeah, that one, that general formula. Could you like tell us how would you derive this formula out?
Oh, okay, I have through about this, but I forget to bring it. I don't know how to say. Is that one is for last time that we study for the Richie Max, and then we let a n equals to r power of n, and then a n minus one equals to r n minus one, and then we count for. We can know that n r is equal to that one, so that finally we can get n equals to this one for the general formula. Okay. And then one, I don't know how to say about that. That solution. What is the name? And then maybe you want to know that I give you.
Any question about Fibonacci sequence? The rest? Okay. Okay, then we will thank the speaker. Okay. Yeah. We'll have a next. Thank you, the speaker. Yeah. The next talk is Roshan about Ramanujan summation in calculus. Yeah, it's going on.
Testing. Okay, good evening, everyone. I'm Roshan, and I'm going to talk about Ramanujan summation in the quantum physics. So first of all, you will wonder that what part do solving the divergence series and regularizing calculations play when using Ramanujan summation techniques in the context of Casimir effect. So I'll tell you about it, the setup and the theory next. In the 1D Casimir effect, which involves two closely spaced parallel plates along a single dimension, the Casimir force, which we call F, can be expressed in the terms of the vacuum density, energy density, which we usually call it U, and between the plates. The vacuum energy density is related to the Casimir force by F equals to minus delta U over delta D, where D is the separation between the plates. Now let's introduce the expression PD, which actually represents the vacuum momentum density from between the plates. So it's actually equals to F, and it's 1 over 2D summation to the Kn, where Kn is equals to M from 1 until infinity, which represents the wave number associated with the end node. So this expression can be related to the Casimir force as follows, which is PD equal to pi over 2 times d power 4 summation of n, where n is summation of n is the divergence series. To make this series, so we can use Ramanujan summation. Using Ramanujan summation, the expression will become this one, which is the minus pi over 24 d power 4. These results represent the regularized or finite value obtained through Ramanujan summation for the originally divergent series. The regularization process in this case involves subtracting the divergence sum from each term to obtain a finite value. Hence, the normalized between the energy between the boundaries amounts to ER equals to dPRD. If we consider the boundary at the D as flexible, we obtain the force acting on it, which is this formula, as previously mentioned. So why do how do mathematics undergo in my living? So I can summarize from these 5 aspects, which is finance, shopping, technology, decision making, and science. And why do I study mathematics? Is because I think I have the passion in it, and it also enhances my critical thinking and provides me wide career opportunities, and also lastly helps me to solve my problems during in real life situation. That's all from me.
Any question? From the MIT first? Yeah.
To know more about this class.
As As I mentioned, Casimir force is the F equals to negative delta U over delta D, and we can derive this formula out of some physical methods, and we get the right size equation, which is 1 over 2D summation of Kn. So to make things easy, we will apply the Ramanujan summation to make the whole calculation more easier, which we can get this at the first step. Pi over 2d power 4 summation of n. Then when we continue to use the Ramanujan summation, finally we will get this one, which is we can prove is the same as the previously one. It helps to calculate the Casimir force lah. When you are encountering with quantum physics, you might want to know the force between the separation of the distance, the force that occurs between the two plates. You might need some formula, which is this formula, to calculate it.
Is this summation still work for higher dimensions of calculation? I mean,
Throughout my research, I actually found that it is valid, but due to the project's situation, I could not explain too much about the higher dimension one, but it does exist.
one more, one. Casimir force, what's the delta actually?
Delta is the changes of U. Yeah, it's a notation.
Also, is that?
This is the formula provided. It's a formula that I could not change. That might be an interesting question. From my knowledge currently, I think it's mainly about the direction lah. You might have, if you have negative ones for the delta U over delta D, then you might negative.
Okay, thank you, speaker.
So next up, we will have Han Wei. Tell us about the boson statistics.
Okay. My name is Han Wei. Today I will talk about boson. So first, this is my flow of the presentation. Start from both identity, and I will explain the partition of and partition integer, and to the application of function in bosonic statistic. Finally, I will talk about the two questions. So both statistic is actually a type of quantum statistic that apply to physical system, consists of a collection of identical and non-interacting particles that can have same state. All the particles that obey this statistic is called boson. So the partition of potential integers, so we denote it as partition function first for the convenience purpose. So it is a partition of an integer in a way of writing the n as the sum of partition integer we call part, where the order of subdivision is not significant. So we can see that as the n is getting larger, the is a rapid growing function. It will grow rapidly, even up to more than 6 digits. So we would like to find a formula for it in a so in 1918, Hardy and Ramanujan had proved the asymptotic formula. Then, based on his work, their work, the Rademacher also proved an exact formula for partition function and is a form of convergence series. So now I will show a simplified model with like an simple example why the partition function can work in Bosnian statistic. So in one dimension Bosnian harmonic oscillator with equal to h bar omega, the given the energy level can be occupied is h omega j, and j can be 0 to infinity. And for the way of diffusion particle, you can see in the figure, there are only 3 ways. And because of the indistinguishable of the particle, so you may look at the middle one here. If we let these two particles interchange, is still because we cannot, so it count as one. So total is 3. It's like the arrangement doesn't matter. So this is my reference. So how does mathematics integrate with my life? So for me, math is a precise version of logic and reasoning. It helps me understand what is reality and how it works precisely, and help me explain my thought precisely to others. So, for example, we can use the concept of union and intersection. You may look at the picture. So we can combine different properties of different person. We use union, the opposite. Here. So for the lower part, the intersection, when we want to talk about the similarity of this, when it is good in explaining our idea. So why I choose to study math is to consolidate my math foundation in comprehensive way, and also learn different perspective and understanding of math and reasoning from it. Also want to learn something related to math and logic that did not write explicitly on book in internet or something unknown for.
Thank you. So I have a question first. So you have a formula for the PN, right? And then you mentioned that it is a convergence series. So let me need to see why convergence.
Um, actually, I'm not quite sure. Because this thing confusing me. I mean, the whole project has something confusing for very long, so I haven't searched about it and not sure why is convergence series. I just found someone is say it is convergence series only.
Are you curious why is it convergent?
Before you say I'm not think before I think understand. Yeah, for me it's more curious. Yeah, until you talk about it.
Boson obeys this bosonic density. Could you tell me more about what is actually a boson?
If I am not mistaken, it can be defined by the number of the spin. It is I'm not sure is 1/2 is fermion. Yeah, 1/2 is fermion. Is one is I mean like the spin is one is boson. Yeah. Uh, Example of boson is the photon and the phonon, if I'm not mistaken. But you can search online. There are a lot of examples.
Any other?
I think you can, I mean like For example, in this class, there are 10 people, so we can classify in how many partitions, so like this. Can you imagine? Oh, okay. Never mind. So I mean like, for example, there are 5 people here, so you can classify into either 4+1, you mean 2, I mean, or 3+2, or 3+1+1. Each is count as 1. And the arrangement is not important. Yeah. So that for the 5 people, you actually can have 7 type of partition.
Other questions? Okay, let's send the speaker again.
Next up, we will have Kuan Ye. Kuan Ye about the Maclaurin series approximation of electric field transition.
Okay, so I'm Guo Kuang-Ye, and my topic is Maclaurin series approximation of electric field intensity calculation. So first up is some background info you can check afterwards. And from high school physics, we know that in this kind of electric field at point x0, we know the electric field intensity can be calculated with this equation. And Ex is only dependent on x since they are not constant. And in this case, x is much larger than a. We took x0 and then x0 for evaluation, where n is much larger than 1. You use Ex and Enx to denote the intensity at point x0 and x0. So here is my question. What is the relationship between Ex and Enx? So the natural line of thought is to follow these 3 steps and hope that we can get expression that we can have Enx be equals to an expression of n times Ex. So when we do likewise, we can see that it doesn't really work. So maybe we can do more changes on the equation to make our way work. Here's Maclaurin series come in, and it's basically a binomial expansion. And we just substitute a over x and k equals to -2 to get this polynomial. Since our x is much larger than a, so we can like have these items be approximated to 0 since we already know this reason. And because n is much larger than 1, like we said before, so nx is much larger than a, we can use the same approximation. Therefore, we can get Enx be approximated as Ex over nq. So mass and life section. How is mass entangled with my life? I believe the main way is that mass can analyze data, find a pattern, and somehow predict the future, which really shapes my life. Like in high school, we just suddenly got more mental health classes because our local government just finds out that there's a correlation between student suicide and the number of mental health class. And my mom just suddenly realized that she should drop investing in real estate market because she saw this Python model based on gradient descent that predict the future of the real estate market. Why did I choose to major in math? Well, 2 reasons. One, because I'm not too sure about my future career path, except that it will be related to science, and math is considered as the center of science. So I just think I should choose math to give me some time before I decide on the specific path. Second reason, math can give me some insight about the path I'm gonna choose, like learning probability, maybe can show me whether I will be good in statistics or not. Yeah, like that. So Q&A. Yeah.
Okay, thank you.
But why do we need the approximation? I mean, why do we need to use the approximation version?
Right? I'm guessing your question is why do I need to use this approximation since we already have this ugly equation here? Something like that? Yeah, because I can't really hear you. So the reason why we need this approximation is that usually in more advanced physics, I think we don't just stop at getting the electric field intensity. We need to like maybe substitute this equation in some other equation to find a more complicated result for some other things. So maybe we need to do some like differentiation and integration, which is really popular in physics somehow, as I remembered, which I don't really. So with this Maclaurin series approximation, we can get a sort of polynomial thing that will be really easy for differentiation stuff. So yeah.
Okay, if not, we'll thank the speaker.
Next up, we have Larry tell us about the Airy equation in quantum physics. That's okay.
Testing. Testing. Greetings, everyone. I'm Larry, and first I'd like to make an apology because I technically didn't really talk about optics for my session. It'll mainly just be about quantum physics. All right, with that, we can begin. So first, we can review power series, which I believe all of us here know what power series are. So I will just show you this. And all right, now let's just get to our main question, which is, if we consider a charged particle and we'll move it along the x-axis into a uniform electric field, then we get F equals to Q epsilon. And this potential energy is just U equals to negative Fx. Thus, we from the Schrodinger equation, we can have it to try and find a wave function which is given here. So here psi will be the wave function, which is what we want to solve the ODE for. All right, so first we can use xi equals to x plus e over f such to make a change of variables and reduce it to Airy equation, kind of. And so we can just assume that psi is has a power series solution, and by differentiating by term, we can get psi prime and psi double prime for some xi in radius of convergence. So substituting, we can obtain this and deduce the recurrence variations, which is given here. And of course, you can prove this by induction if you want to be more rigorous, but anyways, this is like just how we can obtain the psi as a solution. And well, we have psi here, so we have to convert back to x. It will be a little tedious, but ultimately it's straightforward because it's just ultimately just x plus e over f and then times some constant. And A0 and A1 can be determined by another condition, the energy normalization condition for a function in the continuum spectrum. And so Airy equation is like found in many aspects of science. I just listed one of them. And it cannot be solved with more elementary means, but using power series, we can actually find a series solution. So this highlights the importance of power series in calculus. Okay, so now for some more personal questions. How does math entangle with my daily life? One, I use math to sometimes try to win at certain video games. And other than that, mathematics also helps me find like maybe the best deals in shopping, given a chance. And indirectly, by learning mathematics, I also actually managed to find awesome peers like you to talk to. So thank you for that. So now, why do I first choose to study a mathematics degree? I'll be frank, it is kind of, I'll just say like, I feel like I'm kind of good at mathematics in middle school. So at that time, it just feels like a natural extension. Of course, now at the university, mathematics is a lot more complicated than just some calculations. But despite that, I think I still managed to do pretty well. That's it. Thank you. You can ask questions now.
Yeah, I got a question for you. So you assume that the solution is a power series and then you try and find a coefficient that works, right?
Yeah.
So does all the solution appear in that form or not?
Well, so for here, we can see that according to like ODE, because this is actually a second order linear ODE, so we are expecting two linearly independent solutions to cover the entire solution set. And as you can see here, we have A0 times a certain series plus A1 plus times a certain series. In fact, this A0 and this series, the first series and the second series, turns out to be the linearly independent solution. So with that, we can be ensured that these two linearly independent solutions does, in fact, span the solution set. Yes, it does converge. I didn't immediately talk about it, but we can check with ratio tests. In fact, that it converges for all. It converges for all xi, and so by extension, it converges for all of x.
Let's say you are the like mind. Yeah. Two questions. One is, suppose I give you an initial value. Is the solution unique?
By like more of ODEs, ODE theorems. Yes, having this, if we are given an initial value, this second order linear solution will have to be unique. Yes. Right.
Okay, no more will test Larry.
Thank you.
Next up, we have Roland to tell us about the radiation of stars.
Hello everyone, I'm Roland and today I'm going to talk about the radiation of stars. So a black body is an idealized object that absorbs all radiation that falls on it, and its emission spectrum depends on its temperature. And the relationship between the temperature and the spectrum is given by the Planck's law and the Rayleigh-Jeans law. By classical physics, we know that by Rayleigh-Jeans law, it works for longer wavelengths, but fell for shorter wavelengths. And that's what we are going to see today. So we have the Planck on the left and Rayleigh-Jeans on the right. And we can see that the Planck have an exponential factor. And let's see what's going to happen to the exponential factor. Since we are looking at larger wavelengths, and the lambda is in the denominator. So as lambda goes to infinity, u goes to 0. To see how this function behaves. So when we compute at A equals to 0 at Maclaurin series, we see that the relationship between U and lambda is inversely proportional. So as lambda goes to infinity, U goes to 0. And since U is equals to 0, it's almost 0, so U square will be smaller and U cube even smaller. So we can describe the terms higher than order 2, and when we substitute back to the Planck's equation, we will do cancellations and we will get the expression similar to the Rayleigh-Jeans law. So we have shown that the Planck's law reduces to Rayleigh-Jeans law at long wavelengths. Thank you. And the personal questions, why I have chosen mathematics, I think it did more to my attitude of living, because I think I'm a very slow thinking kind of person, and I always need to have my own pace, but sometimes it's not every time you can have your own pace. So I think when I do mathematics, if I solve the mathematics question, I will feel that my life challenges is not that hard.
Thank you. Very interesting sharing. Any question from the MAT? Yeah. Can you describe more about the equation, or what does it do when you put different variables?
Hello? Hello? It will help you to find the radiation of the stars. It is very closely related to the wavelength, to the temperature, and to we have the Planck's constant like h and speed of light, and we have the Boltzmann constant. Actually, it's a very long derivation if you want to see how the Planck's law and the Rayleigh-Jeans law are derived. But Rayleigh-Jeans law comes first, and the Planck's law comes later. Just that Rayleigh-Jeans law doesn't work for short wavelengths. So after that, when this Planck's law came out, they say that it's a better model for black bodies when you want to model black bodies.
This one, I'm not sure about difficulty, but earlier you said that for different wavelengths it scales, right? Can you maybe say like something like how can I see from the formula maybe?
Maybe it's not fail, it's fell. It's like for Rayleigh-Jeans, right? If the wavelength at the denominator, right, then the radiation will get very high and they cannot get it just won't work for when they initially tried with this formula.
You have nice picture, right?
Yeah, but I cannot plot the graph out.
Okay, no more question. Okay, well, thanks, Roland. Next up, we have about how to do audio conversion from analog to digital.
Apologize if the topic is too simple. Yes. Okay. First, let me answer the questions first. How does math impact my life? So during one mark, my friend asked me, what is 25 times 5? I immediately say 125. So math makes me having less confusions and makes my life easier in terms of calculation. And then when I choose math, unoffensively, I want to learn more. Offensively, I want to skip 1 year of computer science. Okay, let's start. So these are just introduction. How am I going to present some waves which are continuous into discrete data that can be stored in computers? So I'm going to present this Riemann sum. I believe everyone knows, if everyone gone through calculus 1 already, right? And then as the number of rectangles increases, it will be more close to the original function. So what we do in audio conversion is we do sampling volumes. So for example, right here, I just take a random curve on the internet, and then I do the upper random sum. I take the point, and all these points are called sampling times, and then I find the values, and then I make a rectangle out of it, and then I have this blue shaded graph. And then as the number of rectangles increases, I'm able to get more accurate audio when I play it back. And then there's a term here called resolution. So for that, there's 12 bit, 14 bit, and 16 bit as the number of data for each audio, and then the more storage they use, the more rectangles they will somehow make, and then they will have like a more accurate representation of the audio. So one thing we can see in real life is this. So there's this thing called lossless audio in Apple Music, and then like the more high resolution the song, the more space you take up because there's more data, because there's more rectangles in the song. And then one popular one is you do the adjustment in bitrate when you play games in Discord. That's it. Thank you.
I have a question. So do you know what's the bit that a human ear can listen?
What's the so sure about what's the bit lah. If you are talking about frequency, then it will be 20 to 20K, if I'm not wrong.
Thank you. Any MNT students with us? Yeah, Ethan. Hello. Oh, man. I'm wondering, can you explain how does the increased number of rectangles in a region some affect to the accuracy of the defined integral approximation?
All right. So let's take this graph here, for example. So as you can see, when I put the rectangle in this space, it doesn't actually match the graph. But the more rectangles we have, the more it will go similar to the graph. Although this is still not similar enough, I can increase how much rectangles I want, as long as I have time to make a more accurate one. Yeah. So the rectangles always have something that is included in the graph and something that is not included in the graph. When I do an inaccurate sum like this, so I increase the number of rectangles, so go close. You have a representation close enough to the graph.
Any other question for the audience? If not, then this is the end for the first section. First section is not the first section. So we will have a toilet break, okay, 10 minutes, and intermission. So after 5 minutes, we will have a performance, live performance, okay? We have a toilet break now until 6 58, and then there's the light performance before we continue with the second session. Okay? Yeah.
你啊不，这个 delete 啊。
哦，这里我这前面有人。拜拜。哎，你要你看，你看这个这样，我看给你啊。
哦，这个我在那边，在这个这个 U 卡是他的，现在要把它播一下。
然后翻，现在翻。
播一下，我这个有 HDMI
要
了。
卖哦，要卖。
不用，我有 HDMI 哦。
啊，OK 好。
来，我看。
我的声不要卖，我真大声。
哦，是的，是的。
卖，大牌。
这个楼要爆了。哎，还是放这个 VLC 看。
对，我有我的乐器。
角落。
也是有个。
哦，整到这个吧 ，VLC 可以超过不？放歌 ，testing 一下。
有吗
OK， 等一下放。这可以再大，是吗 ？VLC 不是可以爆掉吗？
抱歉了，红色哦。
够大声哎！
它的那个一响，听不到，我觉得。不知道。
要不要叫他 try 一下？等一下。
分享过，是分享过。
你们要听歌啊？什么歌？
我是有效的。
你这个有广告。
哎，有。啊？哎，没有哎，我有那个，我有。没有广告，
没有，这是最 normal 的，这是最基本的版本呢。
这样子开来，有自己弄的。哦，这个是哪里？啊，这是拍点的。哦，啊，这个是我们 VIP，这是 VIP。哎，下来吧，他不放手了。等一下，你要给，哦，这个不聊了。
我想说，
小声哦。
你的那个，你的那个也是这样小声吧？
没有，这个比较小声，刚才比较大声一点。
开了最大声，你开了最大声。
大声
这是 VLC 哦。
这个120。
听给他听一下，你开给他听一下。
没有，这个可以开，这个开。
没有，这个不能大声，这个有120。
来开
给他听一下。
最大声。
最大声啊，全部到。
这不是很大声吗？
全部100了现在。
听不到。贱卖，肯定要贱卖。
这样啊。这样。还是用电话？用电话。电话肯定不大声嘛。
难讲。
刚才我的。下面呢？
反正。
对。不要紧张，不要紧张。打电话。
你电话？
我电话。
电话。
啊。
看他。
他帮你拿麦，谁跟你买？
这边啊，放这。
对，放这。我传出去。
好吧。
大吧，大应该的。
要我问题啊？这个关掉。
不要紧张，不要紧张。
那堵在后面没有人。
冷静点，冷静点，冷静。
关掉啊！
冷静。
关掉，我不管。
今天可以感觉。
没有关系，是一个 performance，只是一个。对吧？
有一点杂音，
对吧？我觉得对啊。等一下，我在那走。
我感觉都。
讲错了。
还是哎，录的吧？还录的是吧？
大声啊！哎，那回去怎么办？这种。杨姐，对吧？OK 啊。没事，就还掉。嘴巴里呢？嘴巴看，嘴巴里呢？那如果你这个，你找到这个片子，可以有费用吗？
什么？
测试费。我的那个给我，我那个。赶紧鼓励，赶紧鼓励。你们一起吹。
好。啊？Next year, next year.
You bring your.
I'll bring my counter.
Okay.
Okay.
Next year. Next year. Say something. Next year 我们要的。Next year 到。Next year 还在你 expert 对吧？OK。
对，你关掉。
Okay. So we have.
我可以讲一下话吗？可以。我有沙丁麦啥？啊？我这个东西哦，我练不到5分钟啊，如果吹错的话啊，见谅啊。
Number one.
The team for 有文字还是太纯素了，是有文字来，是吧？你们看的是是吧？是吗？
Let's give him another round of applause. Fantastic.
招财啊，进宝啊。
应该就很像那种新年啊，那种
对
各种亲戚齐聚，然后叫他们的小孩出来表演。
OK，准备好了没有？
下包加油，下包。
观众先看呀。
OK，好，观众看。
哎，我发现。
Yeah. Sorry lah, sorry lah. Sorry lah, sorry lah.
Okay, very good. That sounds like 5 minute practice, but actually this performance was done in Bukit Jalil before. Correct? Yeah, 10 years later. Okay. Next, first in the list we have Yulian. Yulian will tell us about the calculus in the architecture. Yeah,
有
那个印啊，那个印，那个的印。
Okay, testing. Testing. Okay. My name is William, and my topic is about the calculate in architecture. Here is my contents, but not important because we do not have time. Okay, job, no time. For this part, the Gothic architecture and the harmonic theories. Okay, we can see this picture. It's not very obviously here. Maybe 1/2 and 1/3, 1/4, and 1/5. This building to do this design to make it much more beautiful, I think. Okay, let's speed up. For the Fibonacci sequence number and often used on the design of the building. And the golden section is come from the Fibonacci sequence is closely related to the overall structure of the building. Okay, and the golden section is the relationship between the two is mainly reflected in the ratio of the Fibonacci series. Okay, like this picture, maybe sorry, maybe 21 and over 34 is very close to the golden section. And here is the proof. We can know that this series is about an plus 1 equal to an plus 2, and we divide it by the an plus 1 and get this one. And y is close to the limit is equal to x, and we can get this one and to get the golden section. Okay. And the next part, the angle wall of the Temple of the Heaven of Beijing makes use of the characteristics of geophysics. Sorry. When someone standing in the special location, they can hear the sound of another special location. No time. Future 8. Because when someone stands on one focus and the other one stands on another focus, the sound will like this, and the other one can hear the special locations. For the conclusion, the application of the math knowledge in architecture can make building more beautiful, and at the same time, the visual design of the building will, with the math tools, can make the building have better lighting and maybe ventilation. And it shows that the math is a very the math is a very useful subject and not a 空中楼阁 in Chinese, and it means a building without the basics. Okay, so that's why I love the math as well, because I think math is very useful and math is everywhere. Maybe this laptop have math, this mic have math, and myself have math as well. Okay, that's why I love the math. And for me, about to learn the mathematics, because very simple, I want to be a math teacher, just like the kissing. Okay. Okay, that's all for my part and the QA section.
Okay, thank you, Nguyen. I have some questions. So you see quite a lot of content. I'm interested in particular the first slide. So what's the pyramid about with this?
Golden Bridge.
You have the first slide about pyramid. Yeah.
This one? Okay. Okay. Firstly, the golden tower maybe have numerous golden section, and maybe the wide, tall, and this wide and this tall always have the golden ratios, golden section, but someone now think is just maybe not the design, but someone believes so. Okay.
Okay. So you seems to have Fibonacci sequence. So like just now, I don't also have Fibonacci sequence in the nature, but your Fibonacci sequence appear in the human architecture or
Yeah.
human manufacture. So is human trying to imitate the nature, or we kind of work the same way how the nature works? What do you think?
I think firstly, lots of design come from the nature, and the nature have the Fibonacci sequence as well. And then I think Fibonacci sequence is the tool to make the design much more beautiful. Maybe like this flower is not a real one because it's printed by ChatGPT. Okay. Yeah, but the true rose has this one, the true rose, and this one is the big one. Okay, the two rows have the Fibonacci sequence as well. Okay, so I think we copy it firstly and we do the design.
Any question from the back? Yeah, Hanwei.
I would like to know design the can we follow the golden ratio, or it is like literally they without doing the golden ratio then we but suddenly we found out if they actually match the golden ratio.
Sorry.
No? I mean like they the building they intended to follow the golden ratio to build the building. How the architecture is like, I mean, they follow the golden ratio, but they build just like coincidence to match the golden ratio. I mean, do you understand what I mean?
Or is the architect built using golden ratio, or by coincidence it was built?
Oh, I think they use golden ratio because some scientists think that use golden ratio as much as possible can make maybe the light be better and the air conditioner be better. So I think they use golden ratio to do the design.
It's not throughout your presentation you mentioned that Fibonacci sequence or the good actually aesthetically has make the design or building more beautiful.
Yeah.
And then other than to increase the beautifulness, and actually the golden ratio have other benefit to the building, like safety, safety or what?
Yeah, it's add numerous beneficials. Like I mentioned that maybe it can get more light from the sun if you use the golden ratio. And if you do the air conditioner with the golden ratio, maybe put there, and make it the room more cooler. Yeah. Okay.
Other question? No more question. We will thank the speaker.
Next up, we have Chen Jack. Chen Jack to tell us about rocket. Yeah. Okay.
Yeah, hi everyone. My name is Lee Chen Jiang. The topic I want to discuss today is the displacement, velocity, and acceleration of the rocket. Yeah, go through the theory. I define the three variable is this R is R be the displacement, V be the velocity, and A be the acceleration. And they are all vectors, so they have the vector function like this form ht equal to, okay. Then these two theorem is easy, so we can skip. And then the next theorem is when we differentiate the vector function, we can separate the differential individually according to the ijk. Then the similar to the integral. The theorem 5 is talk about the speed and distance, because this two is scalar, so we have the formula is a norm of velocity is speed, and the norm of displacement is distance. And then see the application. A rocket is launched into some space. So we have the velocity function, and the question is asked to find the velocity when the rocket launch at t equal to 5. So just plug into the function, then we can get the answer. Next question is to find the displacement and the distance when the rocket launch at t equal to 10. So we find the displacement first to integrate the velocity function, so we can get another constant number. So we want to get another information like t equal to 0, then the displacement is 0. So we can get a c equal to 0. Then we have the displacement function. Then we plot the t equal to 10 to find the displacement answer. Then next, the distance is the norm of the displacement. So we can plug into the function, get the answer. Then plus c is the new velocity function. And then the question asks what is the time when the rocket launch with uniformly velocity? Uniformly velocity means the acceleration equal to 0, and then the derivative of velocity function is equal to 0. So we have the derivative function there. So each of the coefficient of ijk must be 0.
Okay.
So equal to 1.
More thing to say.
Okay.
Next
Yeah, just
question.
no,
No?
no,
No more.
no,
This
no,
one finished.
just
That's all.
yeah.
Okay.
No.
So what's your opinion on that?
Opinion on
Yeah. In general.
why choose this course?
Yes.
Because I like mathematics. I like the mathematics.
You just like?
Yes. More than the other.
The rest don't let you have. You still like?
Yeah.
You still like?
Yeah.
Even though the rest don't let you.
Yes.
Okay.
Yes.
Very loyal. Okay. Any question on the presentation? Yeah.
This model, for example, is like in ideal cases, like perfect assumption.
Sorry. Can you repeat?
So when you calculate all of everything, like
yes.
speed, the velocity of the rocket, like do you put any assumption here, or is it
No.
ideal cases?
I assume the another air resistance. No.
Also no air resistance.
No. Just a function. So and then consider the function, we can find the displacement or acceleration like that only. You remove this. Which theorem? 3, 4, 5. 4. Which one would you like to ask?
If my component in RT, SD is not integrable, so it does this theorem hold?
No, must continue. Yes. RT is a displacement function. Displacement variable no function.
So that means this three spatial variable depending on time, right?
GH. Go for that. GH. The function depend on t, and the r is the function is a vector function. So that different. Yeah.
Is it like VP given as such? Can you justify how you get this expression?
Which the function how to come? I just create a function. Just create the general function is like this. Like this ht. So you put the what specific x, y, and z. So I choose a function only. Not necessarily is this.
Other question?
Now I got a question. Okay, when? Okay, let me go first.
Are they actually displacement function or function?
FGH. No. Just a function that depend on t on only. No, not displacement, not velocity, and also not acceleration.
Okay. So I also want you to justify the example. How is a rocket made in Malaysia?
Maybe I cannot. I cannot.
Okay. So you cannot.
I cannot.
You cannot.
I cannot.
But Malaysia hop is on you.
No. Hope on you. Hope on you.
Okay. Okay. Thank you. Thank you.
Okay.
All right. Thank you.
Okay.
Thank you, the speaker. Next thing to tell us about the trajectory of an object in the free fall motion.
Hello. Oh, hello everyone. My name is Lysing. Due to time constraints, let's go try to our topic. My topic is the trajectory of an object in free fall motion. Let's discuss a problem related to our real life. In a shot put competition, someone wants to find the best angle to reach the farthest distance. What is the ultimate angle so that cellmate has the higher chance to win? We only consider free fall motion and don't consider any environmental factor. Here zero is the initial velocity of the shot after being thrown by Xiaomei. Alpha is the angle she threw it, and T is the horizontal displacement of the shot when it touched the ground again. Since our question is a bit long, I briefly mention it. We use Newton's second law of motion and linear motion in calculus 2 to prove our calculation. Then this is our calculation. In the end, we can find that our alpha is equal to 45 degrees. In conclusion, by throwing the shot 45 degrees, Xiaomei will be able to throw the shot to the furthest distance possible compared to other angles. Now, I want to share why I study mathematics. This is because I think mathematics has a very flexible things. It has various way of understanding and solving problem, which is really interesting to me. However, I haven't yet reached the level of flexible problem solving. So I hope I can continue exploring and studying hard in the future. But I think I choose this is too crazy because my head is about to fall off. Mathematics has a significant impact on my life. Many times I use problem solving method to solve problems in my daily life, such as induction and analysis. So problems are solved relatively quickly. Okay, thank
Same. So from the solution you get, right?
Yes.
The angle you get is 45 degree. You have a further throw. How about the angle away from 45? Maybe a bit less or a bit more. What happened?
You want it, if because our sign is between one -1, so is another angle sine 2 alpha won't equal to 1 because 1 is maximum. So
But what happened to the throw? What's the distance?
won't be the 等讲一下don't be maximum distance.
Symmetry about that.
I reply you later.
Last thing we discussed yesterday. Please go and read and then let me know.
Okay, revision.
Okay, read, let me know.
Okay.
Any question for them?
We go so far.
I think it is sem 1. Yes. Because we don't consider environmental factor.
Can you like tell me how do you actually get B from A like that?
Easy. Yeah. Because this is our AT, and then we have two equation. AT will equal to B. B is interval of A. Yeah. Okay.
Aside after this. Why negative is considered in this Because of the law of motion.
Because he
Move downward.
对吧？ Thank you. Huh? J vector.
And also something that's used to it. Not again. It is the infecting problem.
，elbow. My teacher said elbow. Then elbow.
Angle, so the player, your opponent can't get it. And you increase the angle, or decrease the.
Discrete.
Flexible using the angle. Because 45 is the furthest one. So either you increase or decrease, you'll become shorter instead.
Decrease吧。
Okay.
So make sure you decrease the angle when you play a ping pong match. Okay. Thank you, Sling. Okay, next up. Okay, thank you. So we have know-how to tell us about the long-range navigation.
Hi everyone. Today my topic is the long range rate. Sorry. Hi everyone. Testing. Okay. Hi everyone. Today my topic is the long range navigation systems. Okay. Let's see. Okay. Long range navigation system is a radio navigation that widely used before the GPS before the GPS comes up, and it's particularly for maritime and aviation proposal. And this is the long-range navigation unit. And then let's come to the problem solving. So suppose that Station B is located 400 miles due east of Station A on coastline. A ship received the signal from Station B is 1,000. A ship received the signal from Station B is 1,020 microseconds before it's received the signal from Station A. So assuming the radio signal travel at speed of this, okay. So what is the okay, let's find out the equations of hyperbola on which the ship lies. So note that the hyperbola curve has this form, and then we calculate and we convert the times difference into the difference in distance. So and we can find it A equal to 1,225 over 11 miles. And then by using the equations B square equals C square minus A square, you can compute, substitute into the polar curve equations, and you get the final answer. And B, if the ship is due north of B, how far of the coastline is the ship? So assume x is equal to 200 because of the north of the B. So x is equal to 200, and you substitute into the equations, you can find the y is equal to 248 miles. Thank you. And yeah.
Okay.
And okay. Testing. Hello. Okay. So how the maths affect my life? So I think maths affect my life in financial management because especially in calculating the interest rate. Yeah. So okay, the second question is why I study in maths degree. I originally considered two courses which is physics degrees and mathematics degrees, but I didn't get I didn't do well in the UEZ examinations on the physics subject, so I came to mathematics lah. Yeah, that's all.
Okay, thank you. So your maths is about calculating interest rate.
Yeah.
Okay, so you got a lot of money to calculate.
No.
Okay, I have a question for your project. So why are we using a hyperbola curve in this case instead of the other curve?
Yeah, sure. Okay, the hyperbola is used on the Lorentz navigation system is because the hyperbola curve are used to represent the possible locations of a receiver like a ship or an aircraft based on the time travel between the signal received the signal received from two transmitter and the time difference is directly relates to the geometric properties of hyperbola curve. As the ship move along the hyperbola curve, the time difference will remain constant every time because because the PA minus PB is constant for hyperbola curve.
Any question? Any question? Yeah. That's time. Yeah. So according to what you said, the system receives measures the time taken for a response, and then with the response, you can estimate how far it is from the station.
Yeah.
And then, so how can you estimate kind of the path, for example, the parabola in the figure, how you can estimate the parabola when you receive signals?
Okay. Okay, because when you receive the signal, right, and you calculate the time difference, and then you convert the time difference into the difference in distance, which is like this example, the time difference is 1,200 microsecond, and the speed of the wave travels is 980 feet per millisecond. So we can by some simple calculations, you can know the A is 1,225 over 11 miles, and then you just substitute into the hyperbola curve equations. Yeah. Yeah, the lecturer asked me now.
Okay. Then the speaker. Okay, next up we have Zhuojing. Tell us about the speedo RZ. RZR? LZR, sorry. LZR. About the swimming suit. So if you go and Shopee, search for speedo, right, you will find the swimming suit.
Hello everyone, I'm Zhang Zhuojin. I'm gonna to talk about the speedo louder razor. Okay. As you know, the fall swimsuit was set to lessen a swimmer's drag in the water and increase the swimming speed. So in this study, we wanted to compare the effect of increasing power versus reducing drag. This is a model about the speed, and this is a reference actually it's from the textbook. So P is the power being used to propel the object, C is the drag coefficient, and K is the positive constant. Consider the two changes of P and C. These two are the domain of X and Y. Then I use a fractional change in speed resulting from both sides. This is a fraction. Then after the simplifying the fraction, it becomes the function just about X and Y. This is a function. After the first derivatives and combined with the linear approximation of fx, y, then when the changes in power x and drag y are very small, actually the effects are the same. So after the second derivatives, the linear approximation results in an overestimate for an increase in power and an underestimate for a decrease in drag. This is the model graph. So we can conclude that when the changes are very small, the effects are the same. Otherwise, decrease in drag are more effective. You can get from the model graph or go from the analysis I mentioned above. This conclusion. Thank you. That's all for me. This is appendix about the simplifying, and this is my reference. Actually, math entangles with our life, like how to analyze the data of products and choose the one that suits us best, and how to manage our money so that our annual return is the highest. So the reason why I choose the math as my major, that it can be transferred to any other fields in the future.
Okay, thank you. So in your graph, right, can you go back to your graph? Your function is 1 plus x over 1 plus y, right? So in your graph, there's a y equal to 0 point. Is that the place where the graph go up or no? Because it's not clear from this shape. Because you divide, if when y equals to what? -1, where's your y? Y equals to -1. Yeah. So when y equals to -1, does your graph close up? Go to infinity?
Let me see.
Yeah.
Find the deductive.
Yeah, so what happened when the y is equal to the -1? You're dividing by 0, right? When y equals to -1.
Yeah.
Yeah. So is this, can you see that in this graph here?
Well up to but this point doesn't appear.
So you don't take y equals to -1, is it? Okay. Okay. Question? Other question? What?
What? Which? For X or Y? 秋秋。
Real number larger or equal to 1.
Since the P is
What's the definition of
it's just x belongs to the real number. Meanwhile, x must be larger or equals to -1.
Okay, let's thank the speaker. Okay, next we have Xiao Tong. Xiao Tong will tell us about the marginal product of labor. Labor. What's the topic again? Labor. Okay, something about labor, is it? Yeah.
Hello? Hello?
Hello. Okay. Hello everyone. My name is Chao Tong, and my topic today is the Cobb-Douglas production function. And firstly, let me introduce it to you. Okay. The function is used to describe how labor and capital combine to produce products or service. And the alpha and beta in the function means the elasticity of capital and labor. Usually, the sum of them is equal to 1. For the Cobb-Douglas production function, I'm using the partial derivatives in calculus 2 to solve the problem. Partial derivatives focus on how a function changes with respect to one variable while holding the other's variables constant. This is the explanation of partial derivatives. And now let me take an example. For this question, for easier calculation, I first assume k equals to 1000 and L equals to 125 to compute the function. Then I put the requirements of the question into this equation. Ultimately, Q1 will approximate 1510. This value is a linear estimate of Q1 near a given point. For the requirement of question B, additions into the given function, and the answer is 1509.89. This value is the precise output at a given point. Then, comparing with the values obtained from part A, the accuracy of the linear approximation can be verified. Okay, this is the end of my speech. Thank you. And for the reasons for choosing the mathematics course, at first I didn't understand the content of university studies. I thought it was similar to high school, and in the past, I was very interested in mathematics, so I chose the mathematics course. Then the impact of mathematics on my life is mathematics teach us how to analyze problems, find solutions, and cultivate logical thinking skills. Okay, thank
Okay, so you have this production function, right? Okay. So if the can you advise the Malaysia government, okay, how to increase the production if they don't have enough labor? Yeah.
Ask again.
Yeah, ask again. So this is the production function you gave, right? Q equals to A times K to the power alpha times L to the power beta, right? So so can you advise the Malaysian government say if the let's say I change another variable, right? Let's say the capital is not enough now. Okay, how I increase the production?
you. I think the government can maybe they can 他们可以聘请一些那个hire and some workers for to then the for the output and
Okay, so you advise that Malaysian government can hire more labor. Is there a reason they hire people from Bangladesh?
yes, of course.
Yes, of course. Okay, sure. Okay, any question from the other students? Hey, shooting. Okay.
On labor is for increasing the production, right? What if you increase the production but the revenue is not increasing? Is it advice?
Sorry?
If you increase the production but doesn't increase in revenue, it's production.
No, I think it's no because this formula is have contain the elasticity coefficient, and so there might be equals to 1 or greater than 1 or less than 1, and it was equal to 1, that indicating that the change in the proportion of output onto labor and capital is consistent with the change in the proportion of output. There is not the same in just increasing.
So it's like
the begin is increasing, but it will be decreasing when you how to say it will be decreasing when you increase more the capital or
This production function refers to any situation. I mean, there any limitation when we use this production function? Is this perfect under any situation?
I think still I think if you want to calculate your your output of the quantities, and you can yes. The elasticity coefficient is equal to 1, that I answer already.
Let's have the speaker.
Next is one of the most practical projects by Hanwei, how to set your car wheel. Okay. Some of you come from AI Center, is it?
Yeah. Hello guys, today here I'm going to talk about the most fuel efficiency, car design, and driving speed. So yeah, keep it. First of all, we should have the basic knowledge of the work done by the moving car. It can be divided into 3 parts. First one is work by the engine. Second one is overcome the ground friction force. And the third one is to overcome the air resistance. Therefore, based on this, we can draw the formula of the work W done by the moving car. W is PT plus Fs plus mu SV squared. PT here means the engine power, and the Fs means the work done by the overcome ground friction force. mu SV is to overcome the air resistance. And so based on that, we can find the fuel consumption, the formula of fuel consumption. And we can find the expression of the fuel consumption per unit distance. We call it PCR. So what we are going to do is to find the relationship between PCR and mu and V. Therefore, we do first differentiate with respect to mu. And we can see the outcome is, we can see the outcome is V squared. Because V squared is always bigger or equal to 0, so that means as mu increase, the fuel consumption also increase. Then we differentiate with respect to speed. And the outcome is the upper one. It's really ugly, so I threw it into decimals to have this graph. We can see the first part of it is negative. The second part of it is positive. That means the origin graph is first decreasing and have a turning point, then increasing. What we need to do is to find the turning point because it's the most fuel efficient point. How? Turning point is where when the differentiation equal to 0. So therefore, we make the differentiation equal to 0 and find the speed. Here is my conclusion. Just have a look. And actually, I have a question for you guys. Based on my conclusion, based on my presentation, which one to choose? Oh, you guys know the answer? No, not yet. All right. So want to have a guess? Which one is the most fuel efficient? Sport car, sedan, SUV, hatchback, pickup truck, vans. Have you guys got the answer? Keith, please. Small car. I walk. You walk. I say the vehicle, you know. So just choose the Tesla. All right. All right. So I'm going to say the most fuel efficiency. Why not choose the EV, electricity vehicle? And that's all my presentation. And now I'm going to answer the 2 questions. Mathematics affects my life, right? I like to say like my topic everywhere, like driving car, the speed and the shape of the car. And actually, I have searched on the internet. Yeah, the internet was made based on the knowledge of calculus. Do you know that? I just know it by Wikipedia. So I would say if there is no mathematics, maybe we are just monkeys live on the tree. And maybe today you are not teaching us the calculus. You are teaching us how to attract a female monkey, how to catch bananas from the tree. So I won't say how mathematics affect my life. I would like to say if there is no mathematics, no nowadays life, no life. And second question is why I choose mathematics. I guess I was mad at that time. It was a crazy decision. My friends tell me, "Wow, you serious? It's really tough. It's really difficult." And I said, "How hard can it be?" My tears rolling down. Okay, to be honest, it's just a joke. Why choose mathematics? Because I think, from my point of view, many subjects are based on the mathematics, like architectures. I don't know the word. Where? Google Maps. Google. Aeronautics. Everything. I guess everything from my point of view, everything was based on the mathematics. So. How about TCM? TCM, traditional mathematics. Traditional. how to spell? Traditional Chinese medicine, right? Also based on the mathematics. We have learned one like 五脏六腑, and it goes a little relationship with mathematics. So that's my answer because I wanna have my base be built very good. So I choose mathematics as my university subject. That's all my presentation. Thank you for your listening. And now it's question time, right? Welcome to questions. Anyone who, please, hands up, boy.
Are they right?
Yeah.
In your opinion, beside Tesla, which one is the most fuel efficient?
Actually, I would like to say the most fuel efficient one is the sedan. It's not the supercar because we should also take the consideration of the engine power. Obviously, the engine power of the supercar is much bigger than the engine power of the sedan. So I would like to say sedan is the most fuel efficiency above this all. Yeah, and any question else? Like, oh, please.
Yeah. So the most economic car that have
I would like to say it's the most fantastic car in Malaysia, might be. And so, any question else? You think? No, all right. So my presentation is over. Thank you guys. Thank you for watching, listening.
Okay. Okay, thank you very much. Next we will have last three. So we have Zhongyi to tell us about the inflation rate versus the unemployment rate.
Good evening, everyone. So my name is Rizong. So my report topic is inflation rate, employment rate, and labor productivity. So they are the part of determining the formation of a market economy system. So speaking of inflation rate and unemployment rate, one can think of an economic tool called the V curve, which is a curve that explains the negative correlation between the. Okay. So the formula for this curve is like this. So this formula is only relationship between inflation rate and unemployment rate. Now include the labor per. So to economic reasoning, we can also use the partial derivative to find their relationship. Okay, the relationship are these two, positive or negative. Okay, because it was easy to see the relationship in the original formula. So we can add a new variable of labor productivity to this formula. So I think, so what is labor productivity? And then we can also use partial derivative to find the relationship. In construction. In conclusion, is that we can use mathematical method to help us understanding the partial impact of the Gini curve on the structure and system of the economy. So the reason why I choose the mathematical department is I enjoy mathematics and I believe studying mathematics has of option. Okay, and the impact of mathematics on my life is that when I encounter problem, I can hear logical thinking and solve them. Is good.
Okay, we'll go back one slide before. The next one. Yeah. So you say that inflation is driven by the unemployment rate. So meaning if the unemployment rate go up, inflation go up. Is that true? What does it mean by inflation is driven by the unemployment rate? So when the unemployment rate go up, inflation also go up.
Inflation and unemployment.
High unemployment rate implies high inflation. So if more people not getting the job, then the thing gets more expensive.
Yes, I think.
You think?
Yeah.
Okay. Then does that imply that if the inflation rate is low, then the unemployment rate is also, let me think, low? No, not the other way around.
It's negative correlation. Inflation and unemployment.
Negative. So you mean if the unemployment rate go up, inflation come down?
Yeah.
Okay. So does it mean that if I want to make inflation rate down, I have to make unemployment rate higher?
Yeah.
Is it true? True.
True.
So if I want the things not as expensive, then I just fire many people. Is that true?
It's my so I think this beyond my understanding. Yeah.
Maybe you can try and think about it. Yeah, how to control the inflation rate.
Control inflation rate.
Yes.
So
Right. Okay, how to control the inflation rate based on the facts you have done. How to control inflation rate based on the math you have done. Try and think about it. You get my question?
Yeah.
Yeah. Try and think about it. Yeah, you think about it. Okay, any other question? Like?
So if I remember correctly, the green inflation rate for most countries like 2% to 3%, something like that. Like they want that inflation rate like every year, something like that. Yeah. How does that sound to you?
it's me.
Yeah, like I just saw like China has last year is 2% inflation rate, and they think it's a very good number. How does
Inflation rate about 2%.
2%.
Yeah. Can you use your match to describe it? Comment on how they keep the inflation rate. No. Next.
I have time value. So for the inflation rate, we need to consider the time effect.
Yes. Time effect.
Make prediction of
So, 有個網
Yeah, maybe maybe have rate over the question or discussion like we will see your paper. We will see your paper.
Okay. Tommy, do you have last thing to say before you go down? No? Okay. Let's dance Tommy. We have next up eating. Eating will tell us how to do the balancing in the balance. And okay, are you going to dance with Paul today? No. Okay.
Good evening, everyone. I'm Daisy, and today I would like to share the moment of inertia of ballet turning. So first, I would like to introduce two ballet terms that will thread to my speech. And the first one is pirouette. And this term is a French word. And pirouette is a ballet classic. In this movement, the dancer stands on tiptoe or on flat ground, using one or two feet as a pivot point. So if you are interested in the pirouette, you can click on the pirouette example, this, and it will link you to a YouTube video. And the next one is fouette. Fouette is a ballet movement commonly known as whip turn. And in this movement, the pivots on one foot while swiftly whipping the other leg and rapidly rotating the body. So you can also click on this and it will link to the YouTube. And what is the application of movement of inertia on ballet turning? So this is the formula that can calculate the moment of inertia. And the function of leg during pirouette is this. I assume the length of the limbs of this person is 45 cm and this curve is z equals to y squared. And I assume the density to be 1.05 and this is a little bit typo is GCM to the power of -2. So the moment of inertia can be calculated as follows. And the next one is the function of leg during fouette. I assume the length of the that related be 26. So and the length of the leg to be 80. This is a graph that I plot by using decimals of the leg. Yeah. And the moment of inertia can be calculated as follows. So we can find that the moment of inertia during fouette is larger than the moment of inertia during pirouette. So how does the moment of inertia affect turning? So the moment of inertia larger and the velocity will decrease and it is hard to turn. So if we want to turn more fluently, we can take our hand more close to our body and the leg close to our body. And yeah, so this is conclusion. So the main reason I chose to study maths degree is I'm not sure about my future career path yet. So I decided to explore more possibilities during the study of maths. And of course, I like the time spending with maths. And how does maths affect my life is it makes my life more interesting and it allows me to look at the problem from different perspectives. Yeah, so that's all for me. Thank you.
I would like to spend time with Max. Well, you like to spend time with Max. You think that is interesting. I think I should invite you to my Max class and then talk to my student. Okay. Any question for Yixing? question for Yixing? Yeah.
One where you have the person there. Any one of them will work. So integration is integrating like the length, or is it like going around the axis? So what is the integration actually going on? What are you integrating?
Oh, I'm is around the y-axis. Yeah.
Short question. So when I used to encounter moment, right? It's kind of like two-dimensional. So there's one plank and then one force, and then you turn either clockwise or anti-clockwise. So why in this case we need to add a third?
Then because the person is turning, so it will like 就是我可以开 video 给你们看吗？用一点点时间。对。它就一直这样子转，所以它不是平面，它是会形成一个很像立体那样。哎，sorry，我用华语回答。
哎。
I think it's the difficulty of the movement. Yeah, because if we are doing pointe, the moment of inertia is larger, so it is hard to keep on turning, hard to maintain the turning. Yeah. Yeah.
Okay, thank you, Yixing. Finally, we come to the last one of the audience, last but not least, Stephen. You know, the part of the working. So you have a senior here doing the topic. Please expect some questions from him.
Okay. Okay, my name is Jin Feng, and my project is roller debit. Okay. If I consider the following feature, and we have the four objects. The first is solid ball, then a hollow ball, solid cylinder, and hollow cylinder. And let us define the variable. Consider a ball or cylinder that the moment of initial is I, and the mass is m, and radius is r. Suppose the vertical drop of pi is h, and the potential energy is mgh. Okay, now envision the object reaching the bottom, which velocity v and angular velocity the omega. This is omega, and we have a formula v is equal to omega r. Okay, no time. Okay, we have a formula mgh like this. Okay, the 1/2 mv square is you can see. Okay, we can first solve this equation, and we get the answer is like this. V square is like this. Where the I star is the reciprocal of I. You can see that, and we will use the formula again and again. Suppose yt represents a vertical distance level at t, and we have the formula like this. We used it before. And by physics, we have the dy over dt equals to v sines alpha. Then we can plug in the formula in. Okay, we get this ODE equation, and after solving the ODE, we get this. For formula, by formula, the inertia, the moment of inertia I about the z-axis, by Iz is like this triple integral, where rho xy is density of object. We can change a variable to symmetrical integration and spherical integration. And first, determine the I star for solid cylinder. We get the answer is 1/2. And then for hollow cylinder is special. We consider the radius is constant, and we get the answer. The answer is 1.
You jump to the conclusion now?
Yeah. The answer is the answer for solid ball is like this. No. 2/5, and hollow ball is 2/3. The conclusion is the faster is solid ball, and then solid cylinder, hollow ball, and hollow cylinder. Okay. Why I do maths? This take a long time. First, my math grades was terrible at the third year of my junior. Okay. One day I realized I cannot be like this. Then I study hard, and I discover the math is my favorite subject. And this period, I do math is for my interesting. After that, I watch a TV show. It's called The Stronger Brain. Okay, Stronger Brain. I was amazed at the consistent. Their logical thinking is quite well. So I had the idea of entering mathematics department, and I feel I can get more and more. No, I haven't like this. This period I do math is for my interesting and for my family. Recently, I see this. I watch a YouTube channel. Their channel is called BBK Network. I like this video is for debate. I like the cue from hear from a boss. The more effort you put, the money will come naturally. And to sum up, the first I do MAT is for my interesting, and then for my family, and until now, I desire to get more and more. I would like to use different angle to see the world. And I don't know what direction can I go in, but I enjoy the moment I take. That's now. Okay, thank you.
Okay, thank you, Jingson, for your wonderful speech. Give priority to why. How can you comment about this project? Comment and question if you have. Last question. Firstly, just now you derived the formula for the time of the ball to reach the bottom, right?
Bottom. What page? Okay.
13.
13. Okay.
Formula for the T, the time.
Time T. Okay.
I think
Wait.
No. T, time taken for the ball to reach the bottom.
Reach the bottom.
The big T.
Big T and T. Small T. Okay.
Actually, what inspired you to find out this small T?
Huh?
What physical phenomena or one thing is inspire you to find out this small T?
ODE. Use ODE. Use separable method. Is there I answer your question?
Actually, from beginning, what model or what things, what physical phenomena you derive from to find out this T?
By physics knowledge, we have this formula. The mv square is translation, and the second is rotation. You can think about the box. That's what I think. Draw to the skies, and we have a kinetic energy, and when it's rotate, you will speed out the progress you flow the I mean the flow. I think that's why formula comes from. We use the separable method to solve it and get a answer like this.
Okay, for the book. And then last question for you. What is the relationship between the moment of inertia and time taken for the ball to reach the bottom of the inclined plane? What is the relationship between I and T?
I and T.
Yeah.
I is no, T is the value of T is depends on I because of H, G, and alpha is being fixed, and every object has different mass and radius, right? That's why it depends on I because another is being fixed. Another is being
Okay. You actually give a good presentation. Okay. Huh? Okay. Last more? Okay.
Oh, I do the research for this. You can you also can choose to respect to Jack axis. You also can choose respect to Y axis. But this want to choose these two variable. If you change the variable, x. Example x, you want to change this to z squared. Change to z squared. And if you change y, you want to change this formula to z squared plus x squared. Okay, this depends on what you want. What you want. What plane do you want to rocket? Physical way? You mean I don't know why I don't get what you mean. Sorry. Yes. The way will change. The way will change. Yes. Yes. But for that exists from our calculus to for our calculus knowledge, we learn from that exists, right? You learn the formula. Okay. The symmetrical integration. You can review that. Review that formula. Okay. Just let you imagine. Okay.
Back to the inclined plane.
You mean the picture? Okay. Okay.
So this is a straight plane, right? What happens if I make one cut into half and the other side make it to a curved plane?
Oh.
Then I release two same balls. Will they reach at the same time? Which one will be faster?
I don't do the research for this, or if this become very difficult, I think. I think the solid boy also become faster now.
So which one will be faster? In your opinion, which one will be faster?
In my opinion, I think is solid ball.
No, I mean the same ball.
The same ball.
Same time. Straight line and one curve.
I think okay. You know the ball from the is more faster. The ball from the curve more faster. No. I not really true lah. You can check out. You can check.
Any other question? Yeah. No. I don't know. In my opinion, I think the curve one has slower speed, right? Because when you roll down but you go up, it kind of decelerate and then accelerate and then decelerate, decelerate. Yeah.
Go down.
Huh? Go down, but the curve is like somehow you.
They are describing one big curve instead of wave like.
Wave like curve.
So it's like this. Huh? No, he one wave like not just one wave, multiple wave. So I think when you go down one crest, then it start to slow and then go increase slow again. Okay. Yeah. Yeah. Sure. Yeah. If it's slowly increasing, there will be fun. Yeah. But yeah. This one. I mean, there's a deceleration. I think.
If the curve is like a circle.
Circle. Yeah.
No, like for each concave. Concave.
Yeah.
Circle.
Yeah.
How it goes down, you have like the radius between the center of the picture. Uh-huh.
you see.
Uh-huh. So
When you go, I think it's
oh, okay. Yeah. Was kind of the, but I think I feel like my gut feeling say so.
sorry.
Okay. So okay. Huh? Yeah. Can someone help open up the light? Turn on the light. Right. Thank you, Jinson, for your wonderful. Let's wrap up for the day. So thank you for your contribution, your presentation, your hard work. Okay, for today. Can give yourself a round of applause. Okay, you come round. Okay. Let's take a last photo before we leave. Okay. Maybe everyone move to the center. Okay, move to the center. Just sit on the seat. Move to the center. Let's take a group photo before we leave. Just move to center is fine. Okay, sit at the center. Someone can do selfie or what? Yeah, move center. Yeah, good. Yeah, move to the center. Can someone do selfie or not? Wait, how to do selfie?
Jingbo, love. Em chơi
Like selfie. Hey, it seems they are leaving them to take off.
Nhưng mà các bạn mới sòng được nhiều. Các bạn mới sòng được nhiều.
我刚不同版的。
可以脱口罩吗？所以你拿剪掉了。加。还有，是都大车，都你看妈的呀！别开那里，我觉得没人对啊。咦？好像我比较年轻的。OK，谢谢。你们还没有走。好。Okay, so thank you for the attendance. We'll see you in future. See you in future. Okay.
Hey, one thing. Are we going to dinner or not? Where? Yeah. Let's go. Let's go. Where are we going? Genting. We're going to Genting. Wait. Seriously.
笑。
好了吗？
等一下啊。
来个吗？人才。来这里看导演啊。